What we've got here is a glass tube. Inside it, we've got this metal plate, and on the other side, another metal plate. The glass tube is sealed with a tube coming off the bottom and a valve that you can open and close. That position there is the valve open, and this position here is the valve closed. Then that is connected through a pipe to a vacuum pump, which we can turn on, and we can use that to extract the air, to evacuate the air from this tube. Now, this metal plate is connected to what's labelled as the ground on this Van der Graaf generator. And the top end, the dome, is connected to the other side of this tube. So we're going to get a very big potential difference between these two, and we can work out what the direction of that is in a second, because I've got a magnet. Now, this experiment needs to be done in a very, very dark room. So you're not going to see any of this apparatus while the experiment is running. But what I'm going to do is I'm going to set up a very high potential difference by turning on my Van der Graaf generator. I always enjoy this. I'm at 0 volts potential, and if I move my hand towards here, the wire gets attracted towards me because the wire's at a potential. But that's actually charged me up now. So let me show you something. I haven't even touched the wire. Look, I haven't even touched the wire. And then look, I'm looking at this trolley. Oh, could you see that spark? Not even touching the wire. I don't even have to touch the wire. I'm nowhere near the Van der Graaf generator dome. But that's at high potential. You can hear it. Oh, and then you saw that discharging down there as well, I think. Look, it's discharging down there. Can you see that sparking? Look at that. You see that discharging down there? It's all getting charged up just because of this Van der Graaf generator dome. Anyway, let's do the experiment I want to do. I'm going to turn the lights off. Ooh, it's dark. A few things to notice. Well, first of all, let's get my camera adjusted so that hopefully it's more sensitive. Well, that's probably the best I'm going to get. If we look inside this tube, you might just about be able to make out a bit of a purple glow. More the light creeping around the door. A bit of a purple glow right in the middle of the screen. And over here on the other side of the tube, there's another purple glow. In fact, that one's a little bit clearer. You can almost see the outline of the circular plate. You keep hearing the discharge of my trolley because it's metal and it's in this electric field. Anyway, so that's what's going on there. Here's the wire that I was getting close to last time. And if I put my hand near it, you might see, if we're lucky, a little bit of discharge from the wire. No. Oh, saw it then. Just get myself earthed. Things are sparking all over the place. Right, let's move this. Oh. See that? A bit of discharge from the insulating wire. So let's discharge myself from this trolley. Ow. And the trolley's sparking all over the place. You can see that. Right. I'm sure this is safe. Let's just do it one more time with the wire. Move my finger near it. Oh, you can see that discharge. Discharging on this trolley. Ow, ow. Trolley's sparking. Fine. Right, now, let us turn on the vacuum pump. So, there's the switch. You can hear the vacuum pump is running. Right now the valve is closed, so that's boring. Let's open the valve and watch what happens. And you should start to see. Oh, it's sparking. Okay, that's discharge, breakdown, of the air. And then, if you keep watching, you get a fairly stable current flowing. And you can see that. Now, I don't need to leave the vacuum pump on now. I can close the valve in the middle. And I can turn the vacuum pump off, which means I've got to walk around here. Where's the switch? Again, I'm in the dark. There we go. So there we have it. We've now got our glow. I'm earthed. I'm at 0 volts, and you can see that that glow is happening because there is a flow of charge, and so the air inside this is lower pressure, but it's going to be at a non-zero potential. So if I'm moving my finger nearer, I can deflect the beam because of changing the electric field. But I have got a magnet, a little small magnet. What I'm going to do is I'm going to bring the north pole of the magnet towards the beam from behind. So the magnetic field is going to be going out of the screen as you're looking at it, and I'm going to bring it towards the left-hand side of this, and can you see that you've now got the beam being deflected? If I turn the magnet around, the field is now going to be going into the screen as you're looking at it, and can you see that it's being deflected? That beam is being deflected upwards. Well, what's actually happening here is your beam that you can see, this glow, is caused by the gas atoms being excited when electrons collide with them. The electrons are colliding with them because the electrons are being accelerated across a potential difference. But where do the electrons come from in the first place? Well, we have to have a big enough potential difference, which is why I need the Van de Graaff generator. 5,000 volt supply just doesn't do it. We need to have a big enough potential difference in order to pull the electrons out of those atoms. Those mostly nitrogen atoms in the air. Those electrons get pulled out, and then they can be accelerated. So we have to have a high enough potential difference to remove the electrons, and that happens no matter what the pressure is. But the electrons can't go very far. The electrons can't go very far if there is too dense a gas. And certainly they're not going to be able to go far enough to cause excitation, so you'd see the gas glowing. So we need to make the gas less dense, more sparse, so that the mean free path of the electrons, that is the average distance the electrons travel between colliding with atoms, we need to make that large enough so that the electrons move across a big enough potential difference to gain enough kinetic energy that they can cause excitation to an excitation level where, when we have de-excitation, we can see the light, visible light being emitted. Now, I've got a diffraction grating here. It's not very bright, this, so I don't know if you're going to be able to see it very clearly, but let's look towards the end where it's a bit brighter. If I take the diffraction grating and I place it vertically like this, you might just be able to make out some different colours. You might just be able to make them out in the middle of the screen. Okay, so there's our light, lovely purple colour. There's the diffraction grating. The camera's not really designed for this low light level stuff, so it's probably going to struggle to see that. You might be able to fix it in post, but I doubt it. And there you have it. That is wonderful. Now what I'm going to do, I'm going to remove the vacuum pump, and then I'm going to slowly let some air in. As I let the air in, we go through this stage. Now at that stage you've got these lovely sparks emerging. They seem to be mostly emerging from probably the right hand side here and approaching the left hand side. And I say that because the sparks seem to be emerging from the edge where the field strength would be highest and going straight in towards the middle on that plate there. So what you've got here is the electrons where the field strength is highest being pulled out of the atoms. But they have to be going very fast, and not very many of them get to go fast enough to cause excitation. So you don't see very much of the glow, but that's very pretty. Let some more air in, and there we go. We've got no light at all. Now I don't know how much of what I said was complete nonsense then, but kind of makes sense. That is the positive side, I believe. That's the negative side, I believe. Because electrons are coming off this side towards that side. If I did Fleming's left-hand rule, when I had the field coming towards me, so first finger was the field coming towards me, they were deflected downward. I can't twist my hand that way. They were deflected downwards, which meant that the cut. 1 second. I can't do this. Well, I'll pause it and I'll mess around with my hands. Yeah, it meant the current was going this way because the magnetic field was towards us and the force on the electron beam was down. So the current is this way. That means the electrons are traveling this way, that way there, which means that this was the negative side that is Earth. So this Van de Graaff generator charges positively on the dome. Fine, okay. And that's a homemade, not really homemade, gas discharge lamp.